let's get going. Here are the goals for the session, but basically I want to say two things about this. First, this session is very much exposure of scar tissue. This is years of working with development teams as a DBA, as a data pro, and all of the basically horrific things I have screwed up and gotten wrong. And the mistakes, that I've hopefully learned from, I'm trying to present to you guys so you don't have to go through the same series of horrific, painful, excruciating events involving all kinds of meetings. I hate those meetings. And so please, please, please try to take it in that vein. Also, DBAs. Who are DBAs in the audience? Straight up, database developers? Straight up developers. Almost no one. Oh, one or two. Cool, that's great. Here's the good news. Developers, please take this home to your database team. They are doing it wrong. DBAs, you're just not getting it right. Okay, and that's what we're here to talk about. All right, the database is a problem. I had a development team. Came up to me one day. Starting a new project. We need an information persistence layer. I said, that's cool. I'm the SQL Server DBA. What do you want? I'm like, well, we're just going to set up an information persistence layer. I said, cool, that's great. You mean analysis services? Oh, no. We need an information persistence layer. Cool, an information persistence layer. That's awesome. But I do databases. What is it that you're looking for? We need an information persistence layer. I said, okay, cool. The information persistence layer is going to have tables. Yeah, tables. The tables will have columns. Yeah, oh yeah, columns in the tables. Okay, and the columns are going to have a data type. Yeah, there will be something like an identifier, say that uniquely identifies a row in some fashion. We might even call it primary key. Yeah, of course, primary keys. I said, and then there'll be relationships between the tables, so that there's these things we might call foreign keys. They're like, well, yeah. I said, so a database? No. No, not a database. I want an information persistence layer. And so the problem really was that this development team had such bad experiences with databases and database development that they honestly felt that if they could just get the word out of the language, they'd fix a lot of problems. Right? If they just, we're not doing a database because databases require all this extra stuff and all these design things. We're not doing that. We're doing an information persistence layer. And a lot of that was my fault. I'm the scary DBA. That was one of my nicknames. Another one of my nicknames, and one I'm much less proud of than scary DBA, is Rant. Because my name is Grant, and my nickname was Rant. Because I would just go off. And I had to stop, right? But there's a reason I go off. Because DBAs have a task, and the task is really simple. Businesses, crazy though this may seem to development people, actually want their databases to stick around for some period of time. They want that information to stick around for some period of time. Code, yeah, we just replace it, right? Throw out the old stuff, put the new stuff in, we're good to go. If we do the same thing with the database, throw out the old one, put the new one in, it works. Except for that little thing called the data, which went away. And funny, they get really mad when you drop their customer list. Why? But, it happens. So you have to avoid that, right? And that's one of the issues we run into. And so when we get people like David here, who is a developer, and myself, who is a DBA, when we get together, we've got these differences, it creates problems, right? And we're going to talk about one of the problems today. There are two major problems with databases from a developer standpoint. Problem number one is keeping the data, the whole concept of persistence. The fact that we cannot replace it like code is an issue for development and deployment. The other issue is the whole object relational impedance mismatch. Anybody ever heard about that one? The nickname for it is the Vietnam of software development. No, I'm serious. Look it up. Vietnam of software development, and you'll see this long article, and then another long article saying how that article was wrong, and then another long article calling both the other guys idiots. I mean, it's seriously, the whole object relational impedance mismatch is huge. I can't help there. so I'm going to shut up about it. But I can help about this whole persistence thing. I've done this a lot. I've worked with lots of development teams. I've got blood and scar tissues to prove it, okay? Please learn from my example. Don't get all bloody yourself. Here's what we're going to do. We're going to try to get the database, to get it so we're not talking about information persistence layers anymore. So we're talking about databases again. We're going to try to treat a database like code as much as possible. And granted, you can't. You can't all the way. You can't 100% treat it like code. You can't. It's different. It's not code. But as much as you can, you treat it like code. And then you do a bunch of stuff. And by the way, this upsets everyone when I say it, work directly with the development team. DBAs just went, oh, God. And developers went, no. Everybody doesn't like it, but it's something you have to do to make this work, is you get together and talk, right? We don't treat each other in an adversarial thing. We are working on the same thing at the end of the day. We're working in theory, depending on consultant law, we're working for the same company, right? With the same goals in mind. You get a repeatable process in place, and we're going to talk some more about that. You put your database into source control. And honestly, I don't care what tool you use. Yeah, Redgate does a better job of it than anyone else, period. But you don't need to use our tools. You can do it any way you want to. But you get your database into source control. You get it tests so you can validate databases, and you automate this stuff. And that gets you the heck out of there. And then finally, and this is the hard one, DBAs, learn development paradigms. DBAs, who knows the word agile? Okay, and of the hands that are up, who has done an agile process inside of your database through database methodologies? And all the hands went down. One hand is remaining. Okay, good. Yeah, you can leave now. It's hard. Feature-driven development. Anybody done that one? Have you done it in databases? Hands go back down. You should be following the development paradigm, whatever it might be. Not simply saying, yeah, well, on the database, I'm over here, I don't have to pay attention to that stuff. Hook directly into it, because it does two things for you. One, it gives you more control over the database because you are hooked into the developers, you're hooked into the development process, you're talking to those guys. You can control things more and better. And two, you are using their language. And by using their language, they can hear you better, which again adds to your control levels. And DBAs, man, we are all about control. Developers are going, well, yeah, that's kind of bad. DBAs are going, no, it isn't. Right? And it's all about where you choose to control and how you choose to control, not whether or not you control. And I'll talk some more about that. Here's the deal. Process is team glue. You have to put together a process. You have to document the process, and you have to get management buy-in. Tell you another story, another development team I work with. We came up with a process. The process said that every Tuesday and every Thursday we will do a QA deployment, right? Automatically every morning, 8 a.m., QA deployment. Cool, excellent. No problem, we're good to go. Having meetings, having discussions. Everybody signs off. Managers are happy. I mean, and literally, when I say sign off, you have everybody sign the process, right? Literally sign a piece of paper so that everyone's agreed this is what we're doing for real. Friday comes along, I get the phone call. We need a deployment to QA. Well, but, we're going to do Tuesday. Yeah, whatever, fine, I'll do a deployment. Yeah, need some one-offs occur. Support the team, move forward. Cool, do the deployment. Monday morning, phone call. We need a deployment. I said, yeah, tomorrow. And they're like, no, there was a problem on Friday, and we just got to have another one right now. Okay, fine. Support the team, make sure things are going forward. I don't want developers to go slow. I'm going to support them, make sure we're going fast. Get the deployment to QA. Tuesday, of course, 8 a.m., we do a deployment. Wednesday, guess what happens? Anybody?
No deployment.
Yeah, guess what? The phone call rings. I need to do another deployment. I'm not playing nice anymore. I said, no. No way. Oh yeah, we have to have it. I said, okay, cool. I will do the deployment right now. But as soon as I'm done, we're having a meeting. I'm going to bring in my boss and your boss, and the process in. I'm going to rewrite the process, and the process is now going to say, we get deployments anytime we want. And that's what the process is going to say. And we're all going to sign it. And they say, yeah, okay, we'll do one on Thursday. Done. Right? But you've got to, I mean, the whole thing is that you've got to get this process. It's got to be reviewed. You've got to make sure you're going through these things. But you have to follow it. And here's the tricky part. And here's again, developers, I'm on your side. I support you. I came out of development. I am a DBA. And down I really am, because I'm a mean person. And DBA is a lot more fun than development. DBAs, 3 a.m. Phone rings. Servers offline. Procs have gone south. Blocked processes, bad code, missing indexes, all kinds of crazy stuff, right? And you guys go into production and you fix it. Yes? And so at 3 a.m. you do this stuff because you have to. At 3 p.m. on a Wednesday, when you go into production and do the same thing, no. Right? You guys honestly think, that you are all special and unique snowflakes, right? And not only that, but, gods stride the earth, right? Because at 3 a.m. you are. But at 3 p.m. you should be following the process that you guys agreed to with the development team, not cowboying your way onto production and making changes just because you can. The exceptions must be exceptional. You guys have to follow the process. You're just not that special. And nobody's laughing. Not even the developers. She's over there. It's true, right? So please, if you're going to go through the process, you've got to follow the process. You do need, by the way, to come up with a methodology for defining how exceptions will work. Because exceptions are going to come up. There's going to be a 3 a.m., 3 p.m. emergency that you're going to have to, you will be going into production, you will be making changes, because we all know that that's just going to happen. But you have to build that into the process too. Right, so here's how developers think about things. And it's not wrong, it's right. I'm not throwing rocks at it. They sit down, they got their laptop like David has here, they do the work, they test it out, it works on their machine, done. It probably goes through some sort of testing environment, whether we call it QA, financial testing, load testing, user acceptance testing, I don't know. It goes through some sort of testing environment, staging, pre-prod, a million different names for test, right, before we get to production. And this is how they think of it. And it's not wrong. But DBAs, I want you to think about it differently. Instead, I want you to build a deployment process that works like this. You have a production environment you have to protect. So you have to define what goes into production and then work backwards from there. And don't worry about what the developers are doing. Get out of their way. But make sure that you've defined something in prod that's going to protect your production databases, that's going to protect the production processes, that's not going to throw the database away and the data that goes with it in order to support, whatever speedy, fast development processes they're doing. So it looks like this. For me, I want a tested production deployment script. Now, if I'm going to have a tested production deployment script, that means I have to have a copy of production someplace of some sort, some kind of copy of production. And we can discuss what that means at length. But to test that script on, I'm going to generate that script from a label. What, a label? What do you mean? Well, I have everything in source control, so I'm going to label the stuff in source control. That is stuff that has been checked into source control. That is stuff that has been, had the code changes, and the code changes have all come out of source control as well. So instead of going from the bottom to the top, which is the development paradigm, you go from the top to the bottom. This is what I have to have. This is what they have to do. How do we make the two meet is the goal for creating a development and deployment process. Does that make sense? Does anybody think it's just completely insane? Cool, so we're done. That's easy. First off, get your stuff in source control. however you do it, because there's two known states. There's what's in production, which hopefully you do to actually know what's there. No? Maybe? And there's what's in source control. Those are the two known states. Everything else, I mean, what got deployed to QA last week? What's currently on the integration server, the dev integration server? I don't know. What went on the CI last night, the continuous integration server? Wherever they checked in. You know, I mean, we don't know. But there's two known states. There's production and there's source control. So once you get your code into source control, you can tightly couple between the app and the database, deploy the two together, and you have a history of changes. And best of all, this is the one I love, you have auditing. Why do I love auditing? Because when Timmy, the idiot, checks in a piece of code, we can see that Timmy checked in the piece of code. I look at the proc, I scream in horror, right? Blood shoots out of my eyes, and then we go down the hallway and have a conversation with Timmy. Because I know that that's who did it, instead of like having to try to investigate and track down who did this insane thing to my production server, right? So that's the goal. David's going to take it, and he's going to show us how to get the source control.
Cool. So to put what Grant is saying into practice, we're going to demo it in the context of Simple Talk. So Simple Talk looks like this. This is what's currently running in production. If you're in the keynote, you've probably seen Simple Talk already. So this is currently what's in production. And as well as production, we've got several other environments as well. So we've got a staging environment. You can see the environments are different because the window title is different, and they've got the word here as well. We've also got a QA environment as well. And we've got the latest environment. And the latest environment is a special environment in that we configured it, and I'll show you how throughout the course of the talk, so that every single time I make a check-in to source control, that automatically gets deployed to the latest environment without me having to do anything whatsoever. So this is always guaranteed to be up to date with the latest thing in source control. So as well as the four kind of centralized environments, I've also got my own local development environment, which is running on my machine. So here I can make changes and see what they're like before checking them in. Then when I'm happy, I can check them in, and I'll get deployed to the latest environment. So crucially, this is just how I've set it up for our team to work. The tools I'm going to show you throughout the course of the talk work however you want to work. So if you've got environments with different names or whatever, they just work. So we've been tasked to add a new feature to the Simple Talk site. So we've got some custom RSS feeds on the right-hand side here, and what we're going to do is we're going to make a fifth one appear in this list. So as well as SQL.net, sysadmin opinion, we're going to add a new feed to the list. And this is going to be a database change. So let's go ahead and make that change. So if I go into, so for each of the environments, we've got a database. So this is the dev database for my local development environment. So I'm going to go in, and I'm going to edit the RSS feeds table to add a new row to this table, which represents the RSS feed.
And yes, it kills me every time he uses the GUI to do all this stuff.
So I spent most of my time as a C# developer, so I use SQL as I know all the edge cases in SQL because I have to fix all the bugs around the edge cases. But yeah, I spend most of my time in C#. Cool. So this is SQL in the City. Cool. So there we go. We have a new RSS feed in the table. So if we go over to the local development environment and refresh that, we can see that our new feed appears at the bottom. So this is because I haven't checked the code in yet. It's only going to be present in my local development environment. If I go over to latest and refresh that, you can see it's not in the latest environment. And if we go and refresh production, it's certainly not in production because we don't develop on production. We develop on our local development environment.
Damn straight.
So that's the change that we've made, and now we're going to use the Redgate SQL source control tool to check that change into source control. So we've already set up SQL source control. I think it was covered in like the first and the second session today. So we're only going to kind of touch on it very briefly. So here we have my data edit to the RSS feeds table to add in a new, so this is the insert into statement for the extra row that I've added.
Data edit. He's checking data in source control. Okay, wait, how much data? Checking into source control, hang on a second.
So this table's got 5 rows in it.
Oh, okay, 5 rows. But like if we had 5 million, we could do the same thing, right?
So generally, when people kind of say they've got 5 million rows in their table, chances are what that table is like a list of customers or a list of kind of orders that their website is making.
So yeah, so why can't we check that source?
So for every table in your database, so as Grant was talking about, there are two known states, production and source control. And for each of the tables in the database, it's worth thinking about which of those states is relevant for that table. So for, say, a list of customers, the kind of true copy of the list of customers is what's running in production. Like, this is where new customers are being added to the table all the time, or new orders are being added to the table all the time. So that's where the definitive data is. So you never want the list of customers in source control, because you spend all your time just copying it from production to source control. And when you do deployment out to production, you certainly would want to change that table, because this is your organization's data that you have to protect. Whereas a list of countries, or a list of RSS feeds, or a list of states, is the kind of static configuration data for your app. And here, you want the definitive copy of the source control so that you get all the order to. So if Timmy comes along and adds a new country into the world, you kind of want to know about that. So that's why the definitive data for those types of tables should be in source control. So with SQL source control, for each table, you get to choose whether or not it should be source control. And we've configured the RSS feeds to be source control. So here we have a data edit, and I'm going to add save the changes. So SQL source control works with a whole bunch of source control systems. I think we showed you Subversion this morning, so I'm going to show you Mercurial right now. So Mercurial commits to a two-stage process. So what we've done with SQL source control is to write that out to my Mercurial working folder, and then this is the Mercurial tool, and I can just add the new word and click commit. So we've now made that database change, use SQL source control and Mercurial together to commit the change. I just want to show you guys what's going on underneath the covers. So exactly what we are source controlling about the database, just so that you've got kind of a bit more in-depth knowledge about what we're doing. So this is what actually gets put into source control. So this is we basically have a folder for each object type. So this is the list of tables in the database. And then for each table, that has a single SQL file for it. And if we go and look at one of those files, we can see it's got a create table statement in it. So this is the schema for the RSS feeds table. And then if I go into the data folder, we can see the RSS feeds data.sql, and if I open that up, we can see it's got all of the insert into statements. So the crucial thing is that what's going into source control is everything you need to create the database from scratch. It's the create statements and it's the insert statements. And then whenever you want to generate an upgrade script for the database, you can use the Redgate database tech, and we use it automatically in a whole bunch of places, which you'll see throughout the demo, to generate the alter scripts and the update scripts and the delete scripts automatically from the current state of the database and the definitive copy that's held in source control. So let me just check that the next demo is going to work. Absolutely. And then some more slides.
Cool. So here's the thing. Deployments, right? They should be going on all the time. They shouldn't be this one-off, once every 6 months kind of thing. There should be like deployments constantly occurring, right? It's A, B, C, D. Always be continuously deploying.
That's why we were deploying to latest.
Right, yeah, absolutely, right? Continuous integration, right? Continuous deployment. Deployments occurring all the time. Coffee is for deployers, right? It's just how it works. Nobody gets the reference. Wow, okay, fine. Look up Glenn Gary, Glenn Ross when you get home. It's your homework. Anyway, then you'll laugh. Then it'll be fun. In order to do deployments, you need to set up unit testing because you don't want to be dependent on the Mark I eyeball to be the thing that's verifying that things deployed correctly. You've got to be able to automate it. You're going to set up continuous integration, which is a mechanism for automatically doing lots and lots of deployments, which is a beautiful thing because anytime Timmy comes along and breaks the deployment, you have an email that goes out to everybody on the team that says, a deployment broke on this piece of code. I wonder who, Timmy. Right? You figure out who did it, and they have to fix it, and they have to fix it immediately so that you continue to continuously deploy. Because every single deployment is practice. What you don't want to do is have your deployment to production be the first time you ever do it. I've done that. It's fun. That Friday night, 10 o'clock, you got all the backups done, the developers are all standing around waiting, you hit the script. Whoops. Right? Last thing you want to hear during a deployment. So you work on that. Also, copies of production. I want you to use copies of production. Now, having said that, I know you've got a 10 terabyte system, there's no way we can copy production. Okay, you're right, don't. Please don't, right? Unless you bought the stock in the EMC or something. Don't copy production, you can't. But copy the production structure. Copy some bits of the production data that's critical. Copy what you have to in order to adequately test the scripts prior to running them in production where we have to protect everything. Right? Go through the process, and it's hard work. Believe me, I'm not telling you, oh, this is easy, no worries. This is, it's fun, have fun, it's easy. No, this is labor. Right? And I hate labor, I'm lazy, I want to lay around. But it's less labor than the recovery process will be. Absolutely. And also fewer meetings. It's long, long meetings. We try to determine how we prevent this from ever happening again. Right? Aren't those fun? No. So let's avoid them. Go ahead.
Cool. So what Grant was talking, the continuous integration system automatically deployed the change that I just made to the latest environment. So if we go to the latest environment, so it used to have 4 feeds, and if we refresh it, we can see that SQL in the city will appear at the bottom. So that's it. I made the change, I committed it, and it's now in the latest environment. If I go ahead and take a look at QA and just refresh that, you can see that that's unchanged. So automatically, on every single commit, we're deploying to the latest environment, practicing the deployment, and checking that it deploys successfully. The other environments aren't affected yet, but as we'll see in a bit, we will go ahead and promote the change to other environments. I just wanted to show you that the change we've made has already made it into the latest. Cool. Okay.
Test your rollback?
Sorry?
You can also test your rollback?
You could set it up to test rollback, yes. I haven't done that now, but yes, you're correct. You could set it up to do that.
I think you're saying, do we test rollbacks as well?
Not out of the box, but you can set that up. It's a bit of work. If you come see us at the end, you can have that.
Okay, speaking as a DBA, not as a developer, rollbacks are hard. Rollbacks are wicked hard. And it really depends on the changes involved, whether or not we can do a rollback. But any of the ones we can do, I would suggest you try testing it, yes. But there's going to be ones you can't do it. And boy, those are fun when they screw up.
It's also worth distinguishing between 2 different types of rollback. So you have, let's say that partway through the deployment, something goes wrong. Because we always do the deployment in a transaction, if something goes wrong, we just roll back the transaction, and production or wherever you're deploying to is just put back to where it was before. So those types of rollbacks, our tools just handle automatically because we always deploy in a transaction, and if any part of the deployment fails, the log gets rolled back. Separately, there's the other kind of rollback, which is the deployment's done, it succeeds, but just as in the keynote, we realize it causes a problem with our production system, and we want to undo it. And that's the kind of problem that, let's say you just deployed a new table or a new column to a table. If you wanted to undo that deployment, it would involve dropping the table or deleting the column. But then the problem is, well, what happens about the data that's been inserted in there in the meantime? This is the kind of, you basically need the domain knowledge of what it makes sense to do. So maybe you want to roll back part of the schema but leave just the table intact, maybe just take the lot off, or maybe you just want to roll back the website change, leave the database kind of in limbo waiting for the next version. It really depends on what makes sense in terms of what the change actually is for you. So those things are much harder for us to support, which is why we don't do quite as good a job of it. But you can set things up such that it would at least, you can test some types of rollback automatically. Albeit you might have to make the decision that you always want to drop the table, for example, that you just had.
I might be jumping the gun, but can you mess up the data you get, do a get latest, and it'll correct the data? So let's go close 2 rows out of the RSS feed table, then do a get latest. Is it going to say, hey, if you want this change, no you don't, I'll go fix your data.
Can we demo that later?
Yes, so just to answer the question,
Just like to get through our stuff.
just to answer the question very briefly, SQL source control distinguishes between get latest, which is get your teammates change, and undo, which is undo changes that you've made and you haven't committed yet. So to undo stuff, you just right-click on the database, and then in other tasks, it's undo changes. So that lets you, obviously there's nothing to undo because we've committed all our changes, but that lets you undo stuff that you've made but not committed. Get latest is more about getting your teammates changes onto your database. But yeah, sorry, cool, okay, so, right. So let's go ahead and make another change to the site. So these, we've got Steve, we've got Grant in the room, they're both very competitive in terms of their articles on SQL Talk and how many views they have. They both want to have kind of the most views. So we have a feature request from them to, for each article, as well as showing the author and the date and how many comments, also going to show how many views it has as well. So obviously, when an article is first published, we want to start the number of views off at 0 to make it a fair kind of competition. And then whenever anyone views an article, we want to increment the count. And we always want to render the number of views on the page here, just to kind of let them see how they're doing. I hope you know it actually. Go through the article.
No, I wouldn't write PowerShell script. Let's keep going.
Cool. So we're going to head and make that change. And so our previous change was just to static data, whereas this change cuts across both the database, because it's obviously to store the number of views, and also the website to render the number of views and to increment the number of views each time an article is viewed. So the first thing we're going to do is we're going to make the database change. This is a change to the database schema so that we have a record of the number of views that each article has had. So I'm going to go to the articles table, and we're going to add so just as an interesting thing, so this is kind of an aside. Does that part of the SQL runs?
Yes, actually.
Do you want to take a guess what we do?
No. But it actually is, I recognize it.
Yeah, so this will give you null. So this is the kind of SQL I deal with. So these are the kind of the weird edge case bugs in our products. So this used to be a bug in one of our products until we fixed it a couple of years ago. So this is the kind of SQL that I deal with all day, which is kind of the edge cases that we have to get right. It makes more sense if you actually write it like that. It turns out that backslash is a currency symbol in SQL. So anyway, so this is the type of SQL I deal with there. So forgive me for using the design.
Oh, that's cool. No.
Cool. So back on to adding our feature. So we want to store the number of views that each article has. So this is the. So yeah, here we are making the database change to add the views. And let's say that because I'm not a very good SQL developer, maybe I'm Tim. Just starting out. I don't really understand what nulls mean, so I'll just leave it at the default because that'll be fine, right? So we've got here a change to the database schema to add in the number of views that each article has had. So let's go ahead and save that change. So that's the database schema change. Now there is actually a bug in this. Can anyone see what the bug is? It's to do with the fact that we're allowing nulls here. Cool. What's the
Yes,
bug?
well, you would null would not be a valid value for a number of views, it's either 0 or 1.
Yeah, exactly. And crucially, when we deploy this change out to production, because we haven't set a default value for this column, that means that all of our existing articles will have null as their number of views, which probably doesn't really make sense. So clearly we should not accept nulls and have a default value of 0. But let's say I'm Timmy, and I don't realise that. So let's see how I can find out that I've made this mistake. So what we're going to do is we're going to write a test. A unit test for our database to check that we've made the correct change. So here's what I'm going to do. So what this unit test does, so I should explain that we're using T-SQL-T, which is an open source unit testing framework. So T-SQL-T provides a whole bunch of helper methods to make it easier to write tests, and it also will run our tests for us. And then on top of that, we're using SQL Test, which is a regate tool that just basically provides a GUI overwriting tests just to make it slightly nicer. Cool, so here we have our test. Tests in T-SQL-T are written as stored procedures, and this is what the test does. So the test goes ahead and deletes every single article. I'll come to why that's fine in a minute. It then inserts a brand new article into the articles table. It does a select from the articles view, which I haven't changed yet. So let's also go ahead and change the view. The C# app interacts with the table via the view, just the results in foreign keys. So we also need to change the view to propagate our comments up to the C# app. So let's go ahead and do that. Cool, done. So back to our unit test. So our unit test selects from the view to get the actual number of views that the database thinks the articles had. And then at the bottom it checks that the actual value that it gets is equal to 0. So this is kind of how the test looks. It prepares everything, it then tests the product code, and then it checks that it got the right answer. So this line here, at first glance, kind of looks a little bit dangerous. The fact that in the test itself, we're deleting content of the table. And to explain why that's fine, I should explain how T-SQL runs tests. So to run a test, T-SQL executes the store procedure. And no matter what happens, whether the test passes or fails or timeouts, it will always roll back the SQL transaction. And what this means is that in the test, if you want to kind of do things to make the test easier to write or easier to read, it just makes it slightly easier. So for me, this bit of code is really easy to read. It's just go into the articles view and select out the actual value. If I have more than one row in that table, then what would it do? So that's why I deleted from the articles table in the first place, to make this thing make more sense. But the other things that you typically might do in tests is if you want to test a particular table, you might not want to go through the effort of setting up all the records in other tables for all of its foreign keys. So if you know you're not interested in that, there's a helper function in T-SQL, which is just get rid of all my foreign key relationships on this table so that I can just insert records in and not have to worry about how to table. But the important thing is that whenever T-SQL runs this store procedure, it will always roll back the transaction, which is why it's fine. So let's press F5 to add that store procedure into my database, and then we'll go ahead into SQL test and run the test. So there it is, our test fails. So this is great for developers who are kind of just starting out, they don't really know SQL, because they get to essentially find out what they don't know by writing tests for the functionality. It's also great as a long-term thing. So this test is written, and it's not just going to be run today, it's going to be kept around forever, and it's going to constantly get run. So this means if ever, maybe in the future, someone does some refactoring and breaks the test, you get to know about it. And this is one of the things Grant was talking about. By building up tests, it's another way that you can be certain that when you finally deploy to production, what you deploy is actually going to work.
So we never check code in unless it's gone through unit testing, right? At least in theory. Developers, yeah. Oh, you didn't hear me? I said we never check in code unless it's gone through unit testing, right?
Oh,
Okay.
Cool, so let's go ahead and delete the views column and we'll add it back. So this is an int, we won't allow nulls, and this time we'll set the default value to be 0. So let's go ahead and make that change. And we'll go ahead and click run tests. And there we are, our test is green. So we've made our change, okay, it was slightly wrong. But most importantly, we wrote the test, and now it passes. Cool, so at that point I'm going to hand back to Grant for some more slides.
Excellent, more slides. Cool. So, developers, you guys are working. I want you to work. I want developers to work as fast as they possibly can. I want that little gear to scream loudly because it's moving so quickly. It's doing so much work, right? But we are going to go through some sort of testing environment, whether we call it QA or anything else. I don't kind of remember what the label is, but it's going to be tested, right? We're going to validate the stuff that you guys are doing as fast as you possibly can works. And that testing gear is going to be a little bit slower, slightly bigger gear, more cogs. It's definitely going to be slowing things down just a little bit, but it's not going to slow you guys down. You guys go fast, but the testing occurs. We're probably going to do some sort of staging, pre-prod, deployment testing methodology to ensure that we're not going to burn production down to the ground, right? That's a bad thing. That gear is going slower still, but it's not slowing down or stopping development. Development should still be going fast. Now, how many deployments you get out of these different environments, I don't know. It's up to you. You guys figure it out. You may go through this full set of deployments 4 times a day. Great, right? 5 times a day, 20 times a day, I don't know. That's awesome. But you're going to go through these types of processes. And then finally, you're going to hit the big, slow, stupid gear, which is production, but it's something we have to protect. So you're going to be working through multiple environments. I hope at least 3. Dev, QA, and prod. Myself, we had 9. So we had dev integration, continuous integration, QA, financial testing, user acceptance testing, load testing, pre-prod, and production. Okay, yeah, it's hard to figure out. I did a lot of deployments. And deployment automation was the main reason I got around it, because I had to go through 9 environments. You got to have at least 3. It's got to be dev, QA, and production, right? Dev test of some sort in production. If you've got only 2, or if you've got only 1, cool. But probably you're going to at some point burn your system down. You don't want to do that. Right? Let's see how we can deal with the environment.
Cool. So for those of you in the keynote, you've seen Deployment Manager already.
That was me. That was me. Oops, I hit the button.
Cool. So for those of you in the keynote, you've seen Deployment Manager already. So I'm going to go into a little bit more detail here about what it is and how it works. So to do the deployment, we're going to use Deployment Manager. So this is the dashboard. It gives you a nice, pretty kind of view of which version of the software is running in which environments. So as Grant was talking about, you probably should know which version is running on production. The great thing about this is that it not only tells you which version is running on production, 1.7, but it also tells you which version is running on all the environments. So if you've got some kind of plasma screen near your team area, we have one with like our usage numbers and our sales graph. Certainly our DevOps team upstairs have this kind of thing on the plasma. So they can see which version of their software is running in different environments kind of at a glance. You can also see if the last deployment is successful or failed, they're all green, so that's good, it means they're successful. And you can see, so we've only got 1 project here, Simple Talk. If we had more than 1 project, they'd be listed down the left. And these are the 4 environments we've got. But it's completely configurable. So if you've got 9 environments, you've got 9 environments there, there will be a scroll bar at the bottom unless you've got a really wide resolution monitor. But it certainly works great for up to about 6 environments. Beyond that, you can need a wide screen to see. Cool, so how does it work? So Deployment Manager has a central component, which is the website that you're seeing here, where you can set up deployments, run them, see if they succeed or failed, that kind of stuff. And then on all the machines that we're deploying to, there's a lightweight agent which runs on the machine. So if you go into the Environments tab, this is where you configure the different environments. So we've got a latest, a QA, staging, and production. And in each environment, we've got 2 machines. We've got a web server for the website and a database server for the database. So you can add machines to your heart's content here, and you can install a lightweight agent on all the machines you're deploying to. Cool. Okay, so next up, Deployment Manager deploys packages. So to do a deployment, we need to have a machine that we're deploying it to, and we need to have a package that we want to deploy to it. So we have to create packages. We support, there's GUI tools that let you create packages, there are command line tools that let you create packages, however you want to work really. So we have a GUI tool that lets you do it. So if you right click on the database in SSMS, you've got a new add-in to SSMS that adds a new menu item that lets you create the package straight away from SSMS. So on the first page, you enter the credentials to Deployment Manager. The second page, the package name and its version number. The third page is where you pick any static data tables, like a list of countries or the RSS feeds, and then you're done. We also have a command line equivalent, which is what we're using here. So we've got continuous integration set up on this laptop. We're using TeamCity, which is a product by JetBrains, which is free for like 20 build configurations, free build agents. Not only do we support TeamCity, but we support absolutely anything else as well. We support Team Foundation build, so TFS, Cruise Control, Jenkins, Hudson, etc., Bamboo, etc., etc. And the reason why we support them all is because all we have is a command line tool, and an MS build script and a man script that lets you package up the database, and also lets you package up the website as well. So once you've created the packages, either command line or GUI, then we can deploy them with Deployment Manager. So if we go into Deployment Manager, let's say we want to promote the change that's currently in the latest environment to the QA environment. So what's currently running in latest is the change to add the fifth RSS feed for SQL City. So to promote that to the QA, you just click through, click Deploy To, find QA from the drop-down, and click Deploy Release. And that's going to go ahead and deploy that change out to QA. So it's deploying, in this case, just the database change, add that new piece of static data into that one table. But if we made a website change, it would also have deployed that as well. And it will always make sure that it deploys a version of the database and a version of the website that work together. Because when you initially create a deployment, you configure the website and the database that works together. And then we remember that, and as that gets promoted between the environments, we always make sure that we deploy precisely the same thing. So that change is currently sitting on QA. So if we refresh QA, we can see the extra feed appear on the right-hand side, and there it is. So one of the other cool things about Deployment Manager is that packages are immutable. So once we've created the packages, they stay the same. And the cool thing about this is that once you've done some testing in your QA environment, or maybe you have a UAT environment, and your client has signed off on it, when you eventually deploy to production, because the packages are immutable, because we deploy from packages, the thing that you deploy to production is the thing that was signed off in UAT or in QA environment. No longer do you have to worry that, oh, well, go look on this network share and find this thing here. Is that the one they signed off? Well, probably. Deployment Manager just handles all that for you. You can see which versions are running on QA now and promote that to production. In the same way that we just promoted from the latest to the QA. Cool. Cool. Okay, so back to Grant for some more slides.
Cool. So, going through all this stuff, it's all mechanisms for getting integrated between your development, between your database and your app code, right? It's coupling tightly application to database, because you go through source control, you go through labeling or versioning or whatever language your source control system uses. You get these things so that you can go out together. You deploy together. You start singing Kumbaya. You go out with the developers at night, have a beer, you know, it's everybody's friendly. Yeah, no, it doesn't happen to me. At the very least, you got the database and the app code to work together. Right? That's really what we're going for. The one thing I would recommend, though, is that you deploy the database first. Anybody know why?
Harder to roll the database back.
Harder to roll the database back, he says. Yeah, that's one reason. Well, here's mine. Database is more important. No, actually, it's what he said. The database is harder to roll back. It's so much more difficult to do a rollback in some situations. And especially if the app code gets deployed and then you deploy the database and you screw up the deployment through some mechanism, it's going to happen even if you do all this stuff. Occasionally, sunspots, right? Extra solar radiation. Giving away other stories for later today. But anyway, things occur. You may go south. So I would strongly suggest you deploy the database first, just out of paranoia, right? Because it's the more difficult one to get out there. It's the more difficult one to roll back. It's the easier one to screw up. And so get that right, and then do app code. That app code, to a degree, app code is pretty replaceable, pretty easily rolled out, pretty easily rolled back, to a degree. And I realize, I'm not suggesting that their jobs are any easier than ours. Their deployments are a bit easier, quite a bit in some cases.
Okay, so...
sorry, one question.
When we do a deployment, actually, we always create a snapshot on the database in case we have to roll back, we restore it from the snapshot. Is that a good practice?
So you've got enterprise, and they said that they do a snapshot before they do a rollout. Is that a good practice? Oh, heck yeah. That's exactly how I do it, given the opportunity. You have to have enterprise. Otherwise, what do you do? Run a backup first, which, sometimes we would be 4 hours or more to get the backup done, and then some log backups because it took us 4 hours to get the backup done, and all this fun stuff. If possible, snapshots, yes, but only if possible. Not everybody has enterprise.
Okay, so we've made our database change to add in the number of views to the schema database, and now we're going to change our website to render that information. So here's the ASPX page for the home page of the site, and just after the number of comments, we're going to render the number of views. So if I just paste on the clipboard for the code that I wrote earlier. So this is going to render the number of views that each article has. Just to save some time, I'm not actually going to write the code to increment the view count, but you can imagine that's just reading from the database add one and write it back when an article is viewed. So that's our website change. So what we need to do next is to commit to source control. So just as before, I'm going to use SQL source control to script out our database changes. So we've got a table, a view, and the test. So if you save those changes to the directory on our hard disk, then in the Mercurial client, I've got 4 changes. So I've got the table, I've got the view, I've got the test, I've also got the website change as well. And crucially, I'm going to make one commit to Mercurial, which has got the database and the website change together. So atomically, I'm going to commit the database and the website. And what this means, because it's an atomic commit, the way I've set up the continuous integration environment means that it will always guarantee that the packages it creates, that it gives to Deployment Manager, will always deploy this database and this website together. So we never deploy this website with an old database or a new database with an old website. So we have this change will always go out in lockstep. So we'd always deploy both components rather than one, because it also really deploys one part of it. So in this case it doesn't, because we've got a select star in our website. Again, because I'm not really a SQL developer. So yeah, this says select star in the C# code. But if we were to actually pick the individual columns we wanted, then that would be obviously a change to that list of columns. And that means it's actually even more important that we deploy them both together, because otherwise it'll be asking for a column that doesn't exist. So here we go ahead and check the change in, commit the change, and click commit. We'll just add the new test. So there it is. We've done the checking, and now our continuous integration server is watching Mercurial. It's noticed that we've made that change. We should notice we've made that change, and it's about to kick off some builds. While that works in the background, please work. Yeah, it's handy. Awesome. While that works in the background, I just want to show you some more features of Deployment Manager. So the most important feature of Deployment Manager, certainly from a DBA's perspective, is this page. So this is where you get to configure the permissions. So the Deployment Manager lets you configure basically which user, so each user has to log into Deployment Manager. So we're currently logged in as administrator. And this page lets you configure which users get deployed to which environments. So you can see that our continuous integration server, TeamCity, is only allowed to deploy to the latest environment. So this means that we can be absolutely certain that we're never going to have our build system deployed to production by mistake, which I think is brilliant. And my user account has access to deploy everywhere. If you were setting this up in practice, what we'd probably set this up with is something like that, so that my account could only, in fact, I could even deploy to latest. So the build system deploys the latest. I get to promote to QA whenever it's ready for the testing, and then it's only Grant who'd have the mistakes on the right-hand side, which is a great way for him to let me deploy whatever I like to my QA environment. So not just Tuesdays and Thursdays, but take that lead entirely for QA, and then Grant can reappear, and then Grant can reappear in the later environments. And if we had like 9 environments, I might have deployment rights to the second one, and then Grant would have the remaining 7. So the permissions page lets you configure to your heart's content which user accounts can deploy where. Cool. So our build has, while I was talking about the permissions feature, the build has finished in TeamCity. I just want to show you a couple of things. So as you can see, so this is TeamCity showing us what tests we ran as part of the build. So the test that I wrote to check that the articles had 0 as the expected initial count for views and not null is being run by TeamCity as well, and that's got a status of OK. So this is great. Some of your developers might forget to run tests before checking in. So by running the test in TeamCity, and then TeamCity would fail the build if ever the test was to fail, we can know that in the case of, say, Timmy, who doesn't run the test before checking in, we know that the tests are being run by the continuous integration server, and it will email the team if anything goes wrong. If we then go ahead and look at the latest environment and click refresh, we can see that our new feature has been deployed out. So we've got 0 views on all of our articles. And if I hadn't written the code to increment the view count, obviously it would increment it. So it's that easy to get continuous deployments to the latest. It's that easy to get to kind of offload responsibility from the team to maybe deploy out to the test environments that you want them to be responsible for, while simultaneously keeping the permissions just for you to deploy out to the final environments at the end.
Cool. All right, so let's talk about the last thing. Last trick. I don't want to pick on anyone in the room more than I already have. But if you're anything like me, you screw up regularly, spectacularly occasionally, but certainly you make mistakes. And if you can just take the humans out of the equation, write code, create automation processes. They do two things. One, you reduce the number of mistakes because it's code, it's stupid, it does exactly what you tell it. If you tell it to do something wrong, it'll do it wrong, but then you can fix it and then it will do it right from that point forward because it's code. You know, I mean, I used to get like long lists of checklists, right? You know, all these things we have to do for a deployment. You make sure you do this, make sure you do that, make sure you do this. And so you get up there and you're like setting them up and it's like you do them over and over again. So you know, you get 1, 2, 5, okay, good, we're all set. 3 and 4. Ah, damn. Hang on, right? And you screwed up. You got to reset everything, go back, roll back. Hopefully, use snapshots. But you make the process repeatable. Here's the thing: use the tools you know. Who here is using PowerShell? By the way, hands high. I can't see. Oh, almost half the room. It's actually hugely different than normal, but cool. That's great. The other half, why not? But anyway, I don't care. If you want to use PowerShell, great. If you want to use T-SQL, great. Use the tools you know, but automate. You've got to make sure that you get some automation in place because you want to be able to get this stuff repeatable. I supported 7 different development teams all at the same time, in addition to doing tuning for all the teams, supporting production systems, checking why backups fail, all this other stuff. There's 7 other development teams. I had to do automation. Didn't have a choice, right? And it's, you know, because I just couldn't get the job done otherwise. And it's just crazy if you don't take advantage of it. If you're supporting one team and you can sit there and do it all manually, cool. I mean, know if your job becomes available because it sounds like fun. But most others are going to have to be doing some sort of automation. Do you want to? We got like a minute left.
Yeah, I'm going to jump in. So one of the things that the deployment manager lets you do is to run PowerShell as a part of the deployment. So you can do whatever you, so if, for example, there's something you want to do, maybe you want to talk to a load balancer and reconfigure the site somehow, or there's just something that we don't support out of the box, then you guys can get to PowerShell to do that. Because we know that not everybody kind of knows PowerShell or wants to learn PowerShell, despite the fact that you should, because it's a great way to automate things. We've got an example of PowerShell scripts for you. So for all the kind of common things that you might want to do, we've written the PowerShell scripts already. And this is, that doesn't actually have the internet, so I can't show you what's there. But there's a whole bunch of PowerShell scripts. Users are contributing them, we're writing them for all the kind of common things that you might want to do during the deployment. So the great thing about Deployment Manager is it will just run PowerShell either as there's 3 separate phases we let you hook into. So you can hook into before the deployment works. You can hook into whilst the deployment is going on, and then you can also hook into after the deployment has occurred. So you get to hook into all those different bits and kind of control how things are working with PowerShell.
So you can automate setting up the snapshot, run the deployment, and then automate moving the snapshot from the database instead of leaving it in place.
And so even though we run PowerShell, if you guys want to learn, say, how to install batch files instead, or if you want to write it in SQL instead, because we run PowerShell, you can just write one line of PowerShell that says run the SQL script. So even though we only support PowerShell, you can easily leapfrog into whichever language of choice you've got. So I don't think it's just PowerShell that we're constrained to. So the other thing I want to mention, in the last minute left, you see Annabelle hovering at the door.
So
So
less than a minute left, I think we're out.
So the last thing I want to mention is that Deployment Manager is free as long as you've got 5 or fewer projects and 5 or fewer machines that you're deploying to. And then after that, it was paid for tiers. So it's great to get started with, and it does help you automate everything.
Right. Yeah, it's really what was automation. 1 second, and I'll let you know. Hopefully, we talked about everything up here, right? Define a process, whatever it might be. Work backwards from production. I really find working backwards from production is a huge help. You know, source control. It's the only way you're going to do integrate with the development team. And yes, integrate with the development team. I'm sorry. I realize the DBAs are a little smelly. I realize that the developers don't really have social skills. Or maybe I got that backwards. I don't know. But integrate with those teams and test and validate your code and just really automate. If you're not automating, you are doing it wrong. I mean, there's just no other way to say it. I hate coming up here and saying, DBAs, I don't think you're quite doing your job correctly, but DBAs, I don't think you're quite doing your job correctly. And I think developers actually have a better handle on deployment and deployment processes. And instead of us trying to invent the wheel, let's just go and steal from them and you know, go forward from there. Right? Because they've done a good job with it. And that's it. Hopefully we get these goals. And we're going to stop because Annabelle's giving us the stink eye.
I get conclude.
Thanks.